Hello, beautiful people. Today we're starting chapter 1.3, which is about midpoint and distance formulas. So we're going to start with midpoints. So our essential question is, how do we find the lengths of segments with information about midpoints? So a few things we should do is first decide, what does the word midpoint mean? Now, if you're thinking about it right now, you probably have a pretty good guess about what the word midpoint means. And you would probably be right. So I'm going to write a definition. Okay, a midpoint, the definition is a point that divides a segment into two congruent sections. Basically, over here in layman's terms, midpoint is the point in the middle, obviously. The point. Okay, and the middle basically just means that there's an equal amount on the left and the right side of that point. So if you were to fold the line in half or the line segment in half, you'd have an equal amount on both sides. So here is a drawing of a midpoint. So I've got a line. Here are the endpoints. We'll call them A and C. And the midpoint B. Okay. I'm going to label that as a midpoint. Now the important thing is that the midpoint splits the segment into two equal parts. So in order to mark two things as congruent, we put a single line in them. Okay, that line, the black line, means that they are congruent. So AB, the length of it, equals BC, which means that the line segment AB is congruent to the line segment BC. Okay, so both of those statements are true because B is the midpoint. All right, so as soon as you have a midpoint, you have congruent statements. In fact, I'm going to finish that. B is the midpoint of AC. Therefore, so AB equals BC, which means AB is congruent to BC. Okay, so something that we can work off of midpoint is something called a segment bisector. Okay, now again, if you're looking at this word and you're thinking about it, you probably have a pretty good guess about what a segment bisector does, especially if you have an idea of what the word bisect means. Okay, the definition is a point, line, ray, segment, or plane that intersects a segment at its midpoint. So in layman's terms, again, I like seeing the layman's terms, layman. Basically, a segment bisector is any geometrical figure, a geometrical figure that splits a segment into two equal pieces. Okay, so and I get that because a geometrical figure is a point, line, plane, segment, or ray, and it splits the segment into two equal pieces because that's what the midpoint does. So that is what a segment bisector is. That's what it does. Okay, so we're going to talk about finding segment lengths using a segment bisector or a midpoint. Okay, so our first example is this diagram. We've got XY on the horizontal, VW on the vertical, and their intersection is T. And then I have some given information over here on the right. So given means this is stuff that's told to me in the story problem. So the story problem says that VW bisects XY at point T. So that means that this line, VW, is a bisector of XY, which means, if I'm supposed to mark this, that XT is congruent to TY. Okay. It also says that XT is 39.9 centimeters, so I'm going to label that on my drawing too. So as you learn things from the given information, start labeling your diagram. It will help you along the ways. So the first thing that I know is since T is the midpoint, T is a midpoint because of the bisection, so XT equals TY. Okay. The second thing that I'm going to do is to find XY. I know that XY equals XT plus TY because of the segment addition postulate from earlier. Okay, and then I can plug in my numbers.